Observe the visual display, divided into two distinct panels. These panels, though seemingly disparate, portray the self-same entity, merely couched in differing linguistic forms. The sinistral panel, that is, the one situated on the left, illustrates the physical spin vector. Conversely, the dextral panel, the one on the right, depicts the abstract Hilbert space ket, symbolically rendered as psi ket equals alpha up arrow ket plus beta down arrow ket. These are not, I must emphasize, two discrete systems. They constitute, instead, two perspectives from which to apprehend the identical quantum state. Would you, perchance, care to witness how alteration of the physical state, as portrayed on the left, automatically updates the amplitudes on the right? One might observe that the physical tilt of the electron positioned on the left of your display and the mathematical amplitudes arrayed on the right are in fact two descriptive facets of precisely the same underlying object. Modifying the spin angle, designated theta on the left-hand side, directly influences or shifts the balance between the amplitudes alpha and beta on the right. I have taken the liberty of resetting the view, thereby ensuring that both panels are presented with optimal clarity as you manipulate the slider. Ah, yes. Partially correct, I concur. Changing phi does indeed alter the complex amplitude beta by rotating it within the complex plane. However, it does not induce any change in the probabilities of spin up and spin down. This stems from the fact that probabilities depend solely upon the squared magnitude of beta, denoted as the absolute value of beta squared, and the phase factor e to the power of I times phi. The complex amplitudes alpha and beta encode two essential pieces of information: the probability balance between the states and the relative phase between them. These map directly to the latitude and longitude of the Bloch sphere, meaning the sphere is just a geometric summary of the Hilbert space data. Step 2 shows how the amplitude magnitudes explicitly set the latitude. Would you like to see them move together? Indeed, the Bloch sphere transforms abstract complex numbers into a 3D geometric object that is demonstrably easier for human visualization and reasoning. It maps every pure qubit state to a unique point on a surface, where physical operations, such as quantum gates, correspond to simple rotations of the sphere. Step 4 presents the final bridge between these two coordinate systems. Would you care to observe them juxtaposed one final time?